Next up, we are going to be looking at determining the range of tangent and cotangent functions. I can tell you right now, this is way easier than sine and cosine. Let's go ahead and take a look at some graphs. Now, here is the graph of a normal tangent function. We can see it goes up to infinity, down to negative infinity. But I want to look at the unit circle to see why that is. Here's the unit circle. Now, why does it go to infinity and to negative infinity? Well, let's look to see where those asymptotes are. The asymptotes appear at pi over 2, 3 pi over 2, 5 pi over 2, etc. So let's look at pi over 2. As we can see, well, as we know, tangent is y over x. As we get really close to pi over 2, we're going to be taking some y value that's close to 1, but we're going to be dividing by an x value. Sorry, I had to look at that for a second. By an x value that's really close to 0, meaning it's really, really small. Well, if you take a number like 1 and divide by an extremely small number, the smaller the number is, the bigger your answer will be. For example, let's say 0.9999 divided by 0.000001. You're going to start getting into the millions and billions. The closer x, the smaller x gets, the closer you get to pi over 2. So that's why there's asymptotes every pi over 2, 3 pi over 2, 5 pi over 2, and all those increments. So, hence we have a range of negative infinity to infinity for tangent. Now, I want you to see that no matter what you do to A, okay, it's always going to go up that way, right? Because you'll always have that concept of the limit, which we'll talk about in calculus later, to where it'll always behave that way around pi over 2 and 3 pi over 2. And even if you change these b values, you're still going to have that behavior going on at a negative infinity and infinity. I'll even zoom out so you can see. Okay, now again, there is a formal proof for this as to why this happens using calculus, but you don't know calculus yet, right? So I'm not going to go through that, but you can see that no matter what you do here, and feel free to play around with this graph, it's always going to range from negative infinity to infinity, and it's going to do the same thing for cotangent. No matter how you mess around with this, that's always going to be the end behavior. Not really the end behavior because it repeats forever, but the behavior at the top and bottom of the graph. Another reason for that, and I'm not going to go through the thorough proof, but there will always be, you should be able to see that even if you have a bx plus c here, if you set it equal to pi over 2, there will be some x value that guarantees that. So that means there will be this behavior right here, right before that angle, where about y over x becomes extremely big. The same thing goes for 3 pi over 2. And of course that applies to cotangent as well. So the range will always be from negative infinity to infinity. And now for the easy part, the examples. No matter what the function is, I don't care what you do to it, as long as it has some form of a, b, c, and d, it's linear modifications to tangent. The range will always be negative infinity to infinity. There's two ways to write it. You can either write it like this. Actually, I'm just going to write it that way. I'm not going to write it the other notation because that looks better. Oh, and look, I messed up. It should be parentheses around this, right? Not brackets. You never put brackets around infinity. My apologies for that. All right, without further ado, let's take a look at this graph. As you can see, it goes down to negative infinity no matter where you look, and up to a positive infinity. Next example, and the last one, f of x equals negative 7 cotangent of pi x. What is the range of f of x? Well, again, it's always going to be, for any cotangent and tangent function, it's always going to be negative infinity to infinity. So final answer, parentheses, negative infinity to infinity. And this reminds me to fix my mistake that I made. I am a human and I do make mistakes. These should be parentheses. I was so used to my sine and cosine lesson that I kept thinking brackets. Okay, folks, that's it for this lesson. The range of tangent and cotangent is always negative infinity to infinity, parentheses. We can't include negative infinity to infinity because those are concepts and they go on forever. If you have any other questions about this lesson, oh, by the way, this is my cotangent function. This is the cotangent function. As you can see, it ranges from negative infinity to infinity. It almost looks like straight lines. Anyway, if you have any other questions about this lesson, let me know.